I am Gamage PU. I am present in our project on credit card fraud detection. Detecting fraud is quite challenging because the dataset is highly imbalanced, with only a few fraud cases compared to many normal transactions. We used the Kaggle credit card dataset and treated it as a supervised learning problem to predict if a transaction is fraud or not. To do this, we use for deep learning models and compared their results. DNN is our baseline model, works well on tabular data. Autoencoder learns normal patterns and flags unusual ones as fraud. CNN detects hidden patterns in the data to boost accuracy. LSTM analyzes transaction sequences to spot abnormal spending behavior. Now we see how these models help us understand which one performs best for fraud detection. I have trained autoencoder model. First, I imported all the needed libraries and set up the environment for the encoder. After that, I loaded the credit card data and checked how many normal and fraud transactions it has. Afterwards, I prepared the data by scaling the features and trained the autoencoder only on normal transactions. Following that, I built the encoder-decoder model for anomaly detection and visualize its structure to understand how it works. I trained the autoencoder on normal transactions and check the learning progress using training curves. After doing this, I set after doing this, I set a After doing this, I set a cutoff value to identify fraud using the reconstruction error or normal transaction. I tested the autoencoder to see how well it detects fraud. Finally, I summarized how well the autoencoder worked and suggested how to use it.
My name is Buddhini Veeratunga. In Deep Learning project, I use DNN model for credit card fraud detection. First, I import essential TensorFlow and Chaos libraries and setting up the environment for data analysis and deep learning. Next, I load the dataset and display first few rows and columns of the dataset. Next, I do class distribution analysis using bar chart and pie chart. Then I do data pre-processing and feature engineering our for my dataset. And next, display feature distribution of the dataset using charts. And then I split dataset into training, validation, and testing. I built a deep neural network with three hidden layers and a sigmoid output layer to predict fraud, also generating a diagram of the model architecture. Then I compile and train the DNN model with appropriate metrics, callbacks, and class weights, monitoring its performance on training validation data. Next, I visualize training and validation accuracy and loss epochs using plots. Here, I visualize training and validation accuracy and training and validation loss using plots. Next, I do model evaluation and performance analysis. Finally, I do performance evaluation of the DNN model using ROC, precision recall curves, confusion metrics, and prediction probability distribution. Okay, that's all about my function, and thank you very much.
Hi everyone, I'm Mayush. I'll quickly show how I build and evaluate a 1D convolution neural network for credit card fraud detection. Here I import my libraries such as Pandas, NumPy, Matplotlib, and Seaborn Sklearn and scale in the evaluation model. Next, I load the credit card dataset. I use Rescaler for scale the features, reduce the impact outline. When I split data into training, validation, and testing set using certified sample into maintain the fraud to normal ratio. Finally, I reshape the dataset 3D format to CNN can read each feature sequence. There are convert 1D layers, extract local feature patterns, followed by pooling dropout to reduce overfitting. Dense layer handle the classification and sigmoid output predicts fraud probability. I compiles with Adam optimization and binary crossing since this is the binary classification problem. In the training, I trained the model up for 100 epochs and 32 batch size. Learning rate reduction and checkpointing in ensure model stop at the best validation performance without overfitting. Training history analysis. In there I trained the history analysis, accuracy plot, loss plot, precision plot, recall plot, etc. Finally perform the evaluation and analysis. On the test set I calculate some metrics: accuracy, precision, recall, F1 core, and rock. High precision means fewer false alarms, and high recall shows the model catches most fraud causes functions, gives the correct versus incorrect prediction. In visualization, here I visualize the training accuracy for both training and validation set across epochs check learning. Finally, I show feature maps from the first convolution layer. So thank you.
I'm Sandanayaka SR. This notebook implements an LSTM neural network for credit card fraud detection. This module captures temporal spreading patterns and detects abnormal behaviors over time by analyzing transaction sequence. And first, I mount the Google Drive and import essential directories. Likewise, next I load the credit card dataset that we downloaded. This is showing that five rows in dataset. Next one showing the data analysis. This is it. In the next page, this is showing class distribution analysis. In class distribution analysis, this is class distribution in count and percentage. Next one is data preprocessing and feature engineering. This is it. Also, this is feature scaling and normalization. In the feature scaling and normalization, this is showing time distribution, V1, V2, V3 distributions also. Next one is sequence data preparation for LSTM. This is it. This is showing dataset size, sequences, seq length 10 and step 1 likewise. Next one is data splitting and class balancing. In this one showing data split summary and class distribution by set. Next one is LS model architecture design. In architecture design, it's showing model summaries like these layers and its output shape and parameters. In this one, model compilation and training. Uh, this is module compilation. Module compiled with and loss function metrics such as accuracy, precision, and recalls. In this model training, I use 100 epochs, but it's only um, trained 40 epochs. It's because I use early stopping. Uh, it's it's showing training loss, validation loss, and training accuracy like this. This is the training history visualization. It's showing like LSTM model accuracy and model loss like this. Also, this is model evaluation and performance metrics. This is it. Finally, visualization and result analysis. This is showing model accuracy, model loss, model precision, recall and overfitting monitor. These are the performance curves. Also, this is the error analysis metrics. That's all.